Hi comrades, this is going to go through AS Chemistry, the November test for question 19. So in question 19 it tells us that sodium sulfide Na2S is an ionic compound of sodium, Na and sulfur S. Draw a dot cross diagram to show the bonding in sodium sulfide. So we've got, first of all, we're going to have 2 sodiums to 1 sulfur. So sulfur, just say outer electrons only, sulfur is in group 6. So we're going to have 6 electrons in the outer shell. And now to get into a full outer shell, it is going to gain 2 electrons, which I've drawn as dots to show that they weren't its original electrons. And then it's going to become a 2 minus. Each of the sodiums needs to lose an electron to become an ion. So to balance out that 2 minus, we're going to have 2 sodiums. Now you could have drawn it as sodium with 8 dots in its outer shell. That would have been absolutely fine. Or as an empty outer shell. Either way is fine. And that is your sodium sulfide. You got 1 mark for showing a sodium with either 0 or 8 electrons. And sulfur, you had to have sulfur showing with 8 electrons, 6 were dots, 2 were, 6 crosses, 2 dots, or the other way around. And then the second mark was for having the correct charges on. In part B, the table below compares the properties of sodium sulfide. So sodium sulfide, sodium and sulfur. Tells us our melting points. And what we need is the type of structure. So we've got here 1180, 98, 113. So sodium sulfide. Just as a note, we say, well, this has already told us it's ionic. Sodium by itself is a metal or metallic bonding, and sulfur by itself is a non-metal. So that is going to form a simple covalent compound. It's not carbon that can form a giant one. It would have told us if it was carbon what type of giant structure it had, if it was a giant structure. If it's just sulfur, that's a non-metal, so it'll form simple covalent. So we can go with type of structure. Sodium sulfide ionics form giant lattices. Metals form giant lattices as well. You think with a metal, it's just ion after ion after ion. Sulfur, we said before, is simple covalent. So next up, conductivity. And we've got solid or liquid. So we saw this in the multiple choice for ionic. As a solid, no, but if we can dissolve it or make it molten, it will conduct. So I didn't want pour. I've not read the question properly there. So pour, good. Metals are good conductors, and sulfur, simple covalent, are poor. So for this, you get a point for each column, 3 marks. So if you've got giant, poor, good, 1 mark. If you've got here, giant, good, good, 1 mark. And if you've got simple, poor, poor, you've got 1 mark as well for filling out that table. So selenium, oh, this is a nice long one. Selenium is in the same group as sulfur. So it wants you to complete the electron configuration. So what it's going to look for in this is that it finishes P4 in this. So as sulfur does, it's the 4th one in the P block. So selenium is going to be 1s2, 2s2, 2p6. So that's my first 2 periods. then 3s2, then 3p6. That gets me up to argon. Now selenium is in the period below, which goes 4s2, 3d10, and then 4p4. You can quickly check by adding all of these up. If you had these two the other way around and had 3d10, 4s2, that would be absolutely fine. You get the mark for that. And that is question 19.